Hello everyone. Let us continue our next topic. What are subgraphs? So till now we have seen the concepts like what is isomorphic graphs and all, and some of the concepts related to isomorphic graphs and all. So we'll see what are subgraphs. So two graphs G and G1 are, we say G1 is a subgraph of G if the following conditions hold. So if these two conditions hold, then we say that G1 is a subgraph of G. So which are those? All the vertices and all the edges of G1 are in G. The vertices of and the edges should be in the graph G. So which is the subgraph? G1 is the subgraph and G is the main graph. Each edge of G1 has the same end vertices in G as in G1. So if these two conditions hold, then we say that it is a given graph is a subgraph, and the given graph is denoted by uh, the given graph is a subgraph of a G. Here is an example given here. Any graph isomorphic to a subgraph of graph G is also a subgraph of a G. So if any isomorphic graph is there, so then it is a subgraph of a graph G. So which are there are certain consequences of subgraph. Every graph is a subgraph itself. So every graph is a subgraph. Uh, every simple graph of n vertices is a subgraph of a complete graph. So if at all you have three vertices, so then it is also a simple graph. Then it is a subgraph of Kn. If G1 is a subgraph of a graph G2 and subgraph of a graph G2 and G2 is a subgraph of a graph G, then G1 is a subgraph of G. So these are the some of the consequences which needs to be remembered. A single vertex in a graph G is a subgraph of G. Okay, so these are some of the consequences which needs to be remembered when you are learning the concept of a graph. So for a subgraph, so here is a graph G1 and here is a graph G. So which is the subgraph is? So this is a subgraph and V1, V2, V3, V4. So here is a subgraph and this is here is a graph main graph and this is a subgraph. And spanning graph, what is the meaning of a spanning graph? As given a graph G is equal to V comma I, what is this V comma I? V is the number of vertices, E is the number of edges. If graph is a subgraph G1 V1 comma E1 of G such that V1 is equal to V, then G1 is called as a spanning graph, subgraph of G. That is, all the vertices of G should exist in G1. So all the vertices should exist in the G1. So here we have an example. So when we see an example, then we'll come to know that a spanning subgraph. Here consider this is a G this graph wherein and this is subgraph, spanning subgraph. Why spanning subgraph? Because there are all the vertices in this, but certain edges are not there. Okay? A spanning a subgraph but not spanning because some of there is vertex is missing. Here the vertices are 4, here the vertices are 3. So that's why it is not a spanning subgraph. Induced subgraph. Given a graph G is equal to V comma E, suppose there is a subgraph G1 is equal to V1 comma E1 of graph of G such that every edge A comma B of G where A B belongs to V1 is an edge of G1 also, then G1 is called as a induced subgraph of G and is denoted by V1. That is a subgraph G1 of a graph G is called V comma E is called as an induced subgraph. Subgraph if for all V1 is a sub, subset of V and contains all the edges from G denoted by this particular symbol. So induced subgraph. So this is a graph and this is a induced subgraph, and this is not an induced subgraph. So what our induced subgraph says that given a graph is there is a subgraph G1 is equal to E1 comma such that every edge A comma B of G where A1 A1 B belongs to E1 V1 is an edge of G1. So there should be an edge C V1 V1 V2. So here it is a V1 V2. V V2 V5 here V2 V5. Next V5 V3 V5 V3. So there is an edge. Okay. So the naming conventions are also there. But if you consider here V1 V2 V3 V4 V1 V2 V3 there is edge is not there. Okay. But here the edge is not there between V5 and V3, then it is not here. By taking this into consideration V1 V2 V3 V4, so it is a complete graph, and even there is an V2 to V5 there is an edge, but why it is not an induced subgraph? Because between V5 to V3 there is no edge. That's why edge disjoint and vertex disjoint subgraph. So what is this edge disjoint? Let G be the graph and G1 G2 be two subgraph of G, then G1 and G2 are said to be edge disjoint if they do not have any common edge. If they do not have any common edge, then they they are said as a edge disjoint. And vertex disjoint, G1 and G2 are said to be vertex disjoint if they do not have any common edge and any common vertex. So it is a vertex disjoint. Note subgraphs that do not have that have no vertex in common cannot have edge in common. So these are some of the points need to be remembered while dealing with the edge disjoint and a vertex disjoint. Two vertex disjoint subgraph must be edge disjoint, but the converse is not true. Okay, and here are some of the examples of that, and G is equal to ABC and EFG, and G1 and here is G1 G2. G1 and G2 are vertex disjoint subgraph, also edge disjoint subgraph. A to B, A to B, A to C, A to C, and A to B, A to E, A to E, E to F, and these are the subgraphs G1 and G2, and this is the vertex joint. The number of vertices are in G and number of vertices are same in number, and here edge disjoint. So this is graph G1 G2. Okay, A B C D A C A C D. G1 G2 are edge disjoint. G1 G2 are but not vertex disjoint, because and A to C is there, A to D is there, and why not vertex disjoint? So one vertex that is B is missing over here, and we'll see some of the problems later on. And coming to the next concept, we'll have to see the operations on graph, and maybe you can also learn these operations on your own, and this is something which we need to focus more. And in the coming video, let me have some of the videos let me share some of the videos on subgraphs, and maybe even directly onto the trees walk and this and their classification, and let me make a video on trees. So most important concepts I'm covering here, And next, later on we'll see the, maybe if at all you get an opportunity of a offline class, then we'll see some of the examples solved over here. And one thing, if you have any uh, queries, some problems which more needs to be solved, even you can search in the Google. And if at all you have other videos which you like, then you can even see those videos and get the benefit out of it. Okay. And in my next video, let me share the concept of concept that is free. Thank you.